Hey guys, it's Miss Campbell, and today we're going to talk about Euclidean versus spherical geometry. So Euclidean geometry is the geometry that we've been working with so far, and it is geometry that is done on a flat plane, okay, like the board or your desk, okay, so flat surfaces. Now, spherical geometry is the geometry that you find when you go to a surface that is shaped like a sphere, okay, so I brought this beach ball to kind of help us to see the difference between the two. So Euclidean, flat, regular, normal geometry we've been doing. Spherical, things get a little bit different when you come to the sphere. So the first thing we're going to talk about are lines, okay? So a line in Euclidean geometry, okay, a line is just a straight line. It goes on forever in two directions, right? And since it's a flat plane, it's never going to end. It's never going to, have to go anywhere. But let's think about when we have on a sphere. Okay, if we got a sphere, we can trace here. So I'll start here with the top, right? I'm going to trace. I'm going to go along the yellow here. I'm going to keep going and keep going and keep going. And if I keep going long enough, I'll cross over this way, continue over here. Guess what? I'm going to end up back here at the top, right? Okay, so on a spherical geometry surface here, a line, what does it actually look like? It looks like a big circle. So what I just showed you on here, we started at one spot, we traced, and we went around, and guess what? We ended up back where we started because we're on a sphere. We're just tracing big circles. And in fact, in spherical geometry, lines are called great circles. So a line is a great circle. And when they say great, they don't mean awesome, they mean it's just big, okay? Great meaning big. So that's the difference between Euclidean geometry and spherical geometry when it comes to a line. So in spherical geometry, it's just going to be a big old circle because you have nowhere else to go except, to begin and end at the same spot. Okay, the next thing we're going to talk about are parallel lines. So in Euclidean geometry, Euclidean geometry, parallel lines, they just look like this, right? Okay, they're parallel. They're never going to touch or cross, anything like that, because they have a flat surface. They can just keep on going, and they'll never ever end. Well, let's think about a spherical surface. We already drew one line here, okay, and we said it's going to start up here, go back around, and then end on the same spot, right? Okay, well, let's draw a line that's running next to this one, because isn't that what parallel lines are? They're just lines that run next to each other. All right, well, let's start again. We're going to start right here, go around. Oh, look at that. What's going to happen with our two lines? They're going to cross. So because of the fact that the lines on spherical geometry are big circles, that means that there are no such things as parallel lines. And in fact, if you look here, the lines in spherical geometry, any two lines are going to cross in 2 points. Here they're crossing at the top and the bottom of our sphere. In our picture, okay, you can kind of see, it's a little bit harder to see on the 2D picture, but you can tell this line going like this, look, they cross here in the front, and then they also cross on the back of the sphere. So in spherical geometry, there are no parallel lines. So no parallel lines in spherical geometry. Okay, no parallel lines. All right. Now we're going to talk about triangles. And this is the last kind of thing that you're going to deal with for spherical versus Euclidean, and this is the one that we're going to work with the most. So in regular Euclidean geometry, okay, Euclidean, and we're going to actually divide this a little bit differently here, give us some more space. Okay, Euclidean geometry, in a triangle, the three angles add to exactly 180. Okay, they add to exactly 180 degrees. Now, spherical geometry is a little bit different. So we are going to look at our beach ball here, okay? And I'm going to draw two lines on here that are going to be perpendicular to each other. So I'm going to erase, I'm going to draw this one here a little bit better. So now y'all, perpendicular. What kind of angle are they going to make if they're perpendicular? 90 degrees, okay? So we've got 1, 2, 3, all right. So if I draw a line that's going to be in the center of this section over here, it's going to be perpendicular to our one that we've already done. Okay, so I've got this one here. I'm going to get rid of our other one here. Just do this side. All right, so I've got my first line going like this, right? Now I'm going to draw a line that's going to be perpendicular to it, going just like this. So it's going to be perpendicular. We're going to go right down the middle of this section. Okay, so up here, where these lines are meeting, this is a right angle. Okay, a right angle. So I've got my line going like this, my line going like this. They are at a 90-degree angle to each other. Okay, now I need a third line that's going to go through here. I'm going to use like the equator. Okay, I'm going to use it going here across the center. Now, if I'm going around the center here, guess what? This line and this line, what kind of angle are they going to be meeting at? A right angle as well. I'm going to keep on going. Okay, and I know this is not the best drawing. All right, I'm just trying to make it so you can see it on the camera. And again, this line and this line, they're going to be at a right angle. Huh, look at that. Did I just draw a triangle? I've got this side here, right? And then from this line and this line, I think I drew a triangle, right? But look at the angles in the triangle. 90, 90, and 90. Well, wait, 90 plus 90 plus 90, that's going to be 270. What happened there? It added up to more than 180. So that's what happens when we have spherical geometry. In spherical geometry, the three angles in a triangle add up to more than 180. Anything over 180 is going to be a spherical geometry triangle. So right there, we can see already, we have 90 here and 90 right there. That's already 180. And this angle up there has got to be something, right? So let's even just say it's 60, because they haven't marked it, right? So we'll just say maybe it's 60. Well, 90 plus 90 plus 60 is definitely more than 180. So in spherical geometry, the angles in a triangle add up to more than 180. Okay, always more than 180. So that's the difference between the two. And here's a hint. If your angles in a triangle, so they are going to give you three angles. If they don't add up to exactly 180, and then they don't add up to something more than 180, well then you don't have a triangle in either Euclidean or spherical geometry. So just keep that in mind here. Euclidean, exactly 180. That's the only number you can get. Spherical, anything above that. So we're going to try a couple example problems. So here they're saying, would a triangle with these angles exist in Euclidean, spherical geometry, or neither? We're going to add them. So the first one, 128, 85, and 30. Let's add them together. 128, there's 85, 8 plus 5 is 13, 8, 9, 10, 11, 213. Okay, add 30 to that. Okay, 243. So the three angles in this triangle add up to 243 degrees. So is it Euclidean, spherical, or neither? It's going to be spherical. Okay, these ones, 68, 52, and 35. 8 and 2 is 10, carry your 1, 11, 12, so 120. 120 plus 35. 155. Does that match spherical? No, because it's not over 180. Does that match Euclidean? No, because it's not exactly 180. So guess what? This one is neither. Okay, neither. And then our last problem over here, we have 63, 63, and 54. Well, 63 and 63, that will be 126 plus 54, right? 6 and 4, that's 10, so 0, carry a 1, 5, 6, 7, 8. And we still have the 1, 180. It's exactly 180, so what is that classified as? Euclidean. Alright guys, so that's the difference between spherical geometry and Euclidean geometry. So whenever we go on the sphere, things get a little bit different. And where is that important for? Well, think about the globe, right? Okay, think about satellites, think about planes leaving, you know, the recent shuttle launch, all that. They have to take into account the curvature of the Earth. So that's why it's important to know the difference between Euclidean and spherical geometry. Alright, see you guys in the next one.